Alright, James here. Now I've got this TV here that's just coming for repairs, and I've got the impression from some comments on my previous two videos that you guys like the teardown / repair videos. So I thought maybe I'll just do a video of me repairing this TV, and hopefully you guys can follow along and it might be interesting for you. Now, I'll be honest with you, this is not technically a tutorial, because the thing is, unless you are technically minded and quite competent when it comes to working with electronics, it's probably not going to be a good idea for you to be doing this, because I've got special equipment here that isolates me from the mains. So it's actually safer for me to be prodding around inside here while it's live and powered up. If you're doing this at home, you're more than likely not going to have that kind of equipment, and it's not really going to be safe for you to be mucking about with the cover off of this thing while it's plugged into the mains, because there are dangerous voltages in there and you can injure, if not kill yourself, with one of these things. So guys, please be careful, and if you are technically minded and you are very competent with electrics, then by all means, you know, use the advice in the video, but all I'm saying is do so at your own risk, okay? Seriously, please be careful. So here's the TV. It's a Toshiba 23DL series, and this particular model is the one with the DVD player built in the side of it. Now, I'll be honest with you, I don't particularly like the ones with the DVD built in, because realistically, you're effectively getting a kind of 2-for-1 deal. And these TVs are cheap enough as it is, so what you basically end up with is a compromised television and a really cheap and nasty DVD player. There's no such thing as a free lunch. You get what you pay for, and with these you really get what you pay for. They're not particularly reliable, and the DVD players on them are usually very, very nasty. So what I would strongly recommend, in my opinion, is that if you're going to go for that, you might as well just buy a decent standalone TV and buy a standalone DVD player to go with it. You're just going to end up with a much better experience if you do it that way around. Or in this day and age, DVDs, it's old hat, mate. It's yesterday's technology. Okay, so the person that gave me this TV said basically it's not firing up, there's no light, no picture, no sound, not even a standby light. So it's absolutely dead. So the first thing I'm going to do is actually power it up, because you should never take their word for it, because they're obviously not technically minded and you are. So just don't take their word for it, just try everything yourself. And also, I've had situations before where I've had appliances coming for repair and they've actually just fired up straight away, and it's actually been their socket outlet on the wall that's broken and not the appliance itself. So that's a bit of a fail. You know, rule number one, if your appliance goes wrong, try it in a different socket, always, because it could just be the socket itself, and you go out and buy a new one and you are screwing when you find out it's the socket outlet. So it probably is broken and it probably won't fire up, but just in case, I am going to try it. Now, I am going to fire this off of the isolated supply, because I want a limited power source. Basically, I'm plugging in an appliance which I know is faulty, and if you go sticking that in a socket, you're a bit of a fool, because you could end up with pops, bangs, and you could end up doing more damage to the TV than what is actually at the moment. So I'm going to plug it into my isolated supply, because it's a limited power supply and it's not going to end up blowing anything up if there is a short in there or something. So we're going to fire it up now, and the supply is on, and yep, just as expected, there's absolutely nothing. I will just hold in the standby button for 3 seconds and see if we get anything. No, absolutely nothing. So yep, fair enough, she's right, it is completely dead. Now, the first thing I am actually going to check before I take the back off of this is the fuse in the plug. Now, these UK style plugs have a fuse in them, and sometimes the fuse can actually blow, and that's very, very embarrassing when you get something in and it's just a blown fuse. So the first thing I'm going to do is actually just check the fuse. So this is one of those ones where it's actually a molded plug, and you just swing the little door open. And I've got my multimeter here, so I'm just going to check the fuse, and if I don't get a beep, I'm going to be laughing, because this is going to be the easiest repair in the world. No, there's a very definite beep there, so that fuse is absolutely fine. So that's the first thing checked. Obviously that's just an easy thing to check, but it's one thing that is commonly overlooked. Okay, so the fuse is definitely intact, so it looks like we are going to have to take the back off and explore further. Now, this type of TV is a design where the back panel comes off and everything's mounted to this front bezel, so I am going to have to lay this down. So the first thing I'm going to do is put this little soft rubber mat down so I don't end up scratching the front of this TV, although it is actually quite badly scratched already, but I don't want to add to it. So I'm just going to put this down. There you go, it's nice and soft and it won't scratch the front of the TV. So that was the chair, not me. Unfortunately, I've just got one of those chairs that makes fart noises all the time and people think it's you. Right, so first thing that's got to happen is this bottom stand has got to come off. So there's 4 screws holding that in. Now, every TV is different, so unless you've got this exact model of TV, obviously the screws aren't going to be in exactly the same place. But there's usually arrows that point to where all the screws are, and the arrows are a different shape embossed into the plastic, and they actually denote what the screw's purpose actually is. So do pay attention to little markings in the plastic, because they're a clue as to what the screw actually takes off. So that's the stand removed. So now we can go ahead and remove all the screws, and I've got a feeling I'm going to need a spudger to get that off, because I reckon there's clips all around there as well. So we'll just loosen all these screws off, and always put the screws somewhere safe, like in little pots or something, because I tell you, those things have got legs. They go walkies, and when you go to put it back together again and you've got more holes than screws, you know that a few of them went walkies, and they literally do. You'd be surprised. They bounce and they go everywhere. So just, you know, be warned. Put them in pots or something and keep them safe. And as usual, there's 2 that go down onto the circuit board as well, which go on the back here. I'll put those in a separate pot because they're actually different screws. Makes it easier when you go to put it back together. Right then, so that's all the screws out. Take this one out here for the power cord retainer. That's the same screw as the outside ones anyway, so I'll put that in there. Take that retainer out. That's loose. So now that's not going to come apart. We are going to need a spudger to get that apart. Now you do need a proper spudger, because this kind of plastic is that kind of hard brittle plastic that just says absolutely no to screwdrivers, because you will just leave marks like in no time. So I'm using a proper spudger here. Make sure you do as well. You can buy these online, they're very cheap, so just invest in a couple of different ones. It does sound pretty brutal when you do this, but it is just the clips. There we go, that's all the clips undone, and the back's now loose. Nice. Right, okay, so back's off, and we have got a DVD player on here, so you've got to be careful because there's going to be a ribbon cable or something. Oh no, it's just a normal Molex cable. So we'll unplug that. We'll unplug the power cord and pull that through, so we can take the back off. Okay, and that's the back, and as you can see, there is the DVD player, and it is the cheapest, nastiest thing you can ever imagine, so that's why they fail. So yeah, but that's what you pay your money for. Okay, so this is a typical construction for one of these types of TVs. You've got the power supply board in the middle, you've got the processor and logic board here, you've got along the top of the LCD, you've got this LCD driver board, or the T-Con board, and you've got the LCD backlight driver here. So basically we've got absolutely nothing at all. So the first thing I'm actually going to check is that we're actually getting power into the TV and make sure this cord is actually okay. And what we'll do is we'll just test voltages, and we'll go from the AC source here, and we'll work our way along to the low voltage side, or the output side of the board over here. So I've got my multimeter here, and I'll put this on AC to start with, because we're actually just going to measure the back of this connector and see if we actually have any kind of voltage. Right, so I've got power now coming into the TV through the mains cable, and I'm just going to test that with a multimeter, and we absolutely have got 240 volts coming in, so that's brilliant. We've got mains coming in, which means the power lead's okay. I've just realised actually you can't see that meter. It'd be nice if you could see that, wouldn't it? There you go. Okay, so now what we're going to do, we know we've got power coming in. we want to make sure now that it's getting through all of the filtering and through the rectifiers and charging up these main input capacitors. Now I'm going to flick this over to DC now. Obviously we are measuring DC, and I expect there to be about 350 volts on these caps. So I'm just going to take a measurement now from here, and cool, blimey, we've got 390 odd volts. That's quite high. I can only assume that's because obviously the power supply is in a kind of a state of very low power at the moment, because it's not actually doing anything. So I can only imagine that's the reason why those caps are up very high. Right, so we've actually got power coming into the DC side. So now what I'm going to do is just very quickly just check the output side and see if we've got absolutely anything on the output. And we've got absolutely nothing, and the fact that that is actually saying 00000 suggests to me that I've actually discovered the fault already. I think we might actually have a short on this board. And you can see every now and again, look, it's pulsing, it's trying to do something. So that looks very much to me like a short circuit. Right, so we've got absolutely no power going through the transformer and out to the output side. So what I'm going to do is, for now, I'm just going to turn the power off, and I am going to still be very cautious because those caps are going to be charged up to almost 400 volts. I'm very surprised. That's really high, actually. I'm not quite liking that, but it probably will settle down when the power supply is actually working properly. Okay, so we've got the basic kind of topology on the input. You've got the mains coming in, you've got the filtering stage here, you've got a common mode choke, a couple of X-rated caps, a couple of MOVs, you've got a little inrush suppressor, you've got a little fuse here, a little self-resettable fuse, which I know hasn't operated because otherwise these caps wouldn't be charged up. It then rectifies it to DC, charges these caps, and that's the DC side of the circuit. From there, it goes into the transformer, and it is switched via this little switch mode controller here, and there is feedback via this optocoupler, and then we're over to the low voltage side where we've got these Schottky diodes and some filtering on the output. So I'm going to look at this chip and actually see what the part number is, because I think I've already seen that it's an Infineon chip. Okay, so I actually recognise that part number. That chip is an Infineon. It's a current mode switch mode controller chip. Now pin number 4 and 5 is the drain pins, and they connect to the transformer. So they're essentially switching the transformer through some internal FETs. And I believe this chip is boasting about how cool the FETs run, and they can work up to 650 volts or whatever. Anyway, so basically you've got pin number 1, which is ground, pin number 2 is VCC, and you've got some feedback pins and a shutdown pin. The feedback is done via this optocoupler, and there's a circuit on the output for that. And the chip is actually powered through this transformer itself, so there's actually a separate winding on this transformer which powers the chip, and this chip actually has a built-in starting circuit, so there's no need for any of that resistors and all that to boost it and get it started. It actually has that all built in internally. So the chip is obviously not going to fire if the output is dead, because it actually relies on one of the windings of the transformer to power the chip. So what's going to happen is the internal soft start is going to try and fire the chip. It's going to start switching, then as soon as it realizes there's a short circuit, it's going to cut off, and I think that is exactly what's happening. So what I'm going to do is I'm going to get my scope, and I'm just going to probe up the drain pin and the positive pin on this capacitor, and we're going to actually look, and we'll probably see the intermittent switching where it tries to switch and then shuts back off again. Now I'm using my scope meter for this because obviously the inputs are completely isolated. Using a bench scope for this poses its own problems because the common lead is actually connected to mains earth, and sometimes you can cause small explosions, which is not good. So I'm just going to probe between the pin number 4 or 5, whichever, they're both connected together on this chip, and the positive supply, and we should see some switching. And you can see there's little bursts of switching, so it's intermittently trying to switch. But the problem is the chip is cutting in and it's detecting that something's wrong, or it's not receiving the voltage from one of the windings on the transformer, and therefore it's just shutting down because there's nothing for it to run on. That suggests to me that the output is not happening. Could be a problem with the chip, could be a problem with the feedback, or it could be, as I suspect, a short circuit on the board. So before I go any further, I am just going to double check and see if there is any kind of short circuit on the board. Right, so I'm just going to look for a short circuit on here now. Now obviously it's going to be on the output side, because if it was on the input side, then A, those caps won't be charged up, and B, it would have blown the fuse in the plug, and it hasn't done that. So the short is going to be on the output side. So what I'm going to do now is I'm actually going to probe with the resistance mode on my meter across one of these output caps, and initially it should register a short circuit, and what it will do is the resistance will slowly climb, and then eventually it will just read off scale as these capacitors charge up. When you measure resistance across a cap, initially you do get a short circuit condition. Yeah, that's pretty steady, and to be honest with you, I think that 0.3 ohms is actually my test leads. If I just put them together, yeah, exactly. I need to rail that out actually, to be quite honest with you. So it's 0.2. So I'll rail that out, and yeah, we got 0.1 ohm, which is pretty negligible. That's basically a short. Now, unfortunately, a short circuit on a board like this is usually very, very difficult to find, and you have to just kind of trial and error and try and narrow it down. So I'm going to take the approach of basically removing things one by one and try and sort of narrow it down a little bit. So I'm going to unplug this board here, and we're going to try again. See if we've removed the short, which we haven't. It's still shorted. So next thing I'm going to do is actually take this power supply board out and see if the short is actually on the logic board. So we'll just unscrew this now and take it out. I kind of suspected it might have been a short circuit based on the readings I was getting from the output. Even with a dead output, you'd expect to get a couple of 100 millivolts just sitting on those caps. So I'm just going to quickly just check over the bottom and just see if there's anything that obvious that kind of stands out. And I can't see anything on there that's standing out that suggests a short circuit. Right, so now I've removed this board, I'm going to put it on something non-conductive, and I'll just double check again. Right, no, it's still reading a short. So the short is definitely on this power supply board. Right, now a short circuit on a board like this is usually very difficult to find, and you usually find it's actually a shorted component rather than a trace or something like that. So I'm going to use a technique now that's pretty frowned upon in the industry, but it does actually work, and sometimes it's all you've got because it's usually impossible to find. So what I'm actually going to do is I've got a bench power supply here, and I'm actually just going to connect it to the output stage past the rectifiers here, and I'm just going to pass a current through and see if anything starts getting hot or if there's any components that start smoking. Sometimes you can do this and actually clear the fault and find out where it is. So what I'm going to do now is I'm just going to power the supply, and I've got it on a very low voltage, and I've got the current wound right down. So we'll just switch on the output now, and as you can see we've got absolutely zero. If I start winding the current up, so we've got about 160 milliamps there. So that short circuit is pretty solid, whatever that is. What I'm going to do is I'm just going to wind it up to about 0.5 amp. So we've got about 500 milliamps now, and we're going to leave it like that, and I'm going to start feeling to see if any components are actually getting hot. And we'll also check the backside as well. And usually by this point you start seeing little wisps of smoke if you've got a component that's not very well, and I'm not seeing anything here. Let me just have a quick feel to see if anything's getting warm. I'm mainly touching the active components here, like the transistors and stuff. I'm not worried about passives because you know, usually shorted capacitors and stuff will go open circuit at this kind of current. So just double check, that's the high voltage side anyway. No, we've got nothing there, so it's obviously a big chunky component, whatever it is. I'm suspecting at this point it could be either one of these caps. Let's try and wind it up a tiny bit more. So we're up to 1 amp now, so whatever that is, if it's not a large component, it's going to be getting pretty hot right now. Transformer's not getting warm, so we're not leaking any current back through those rectifiers. Right, so I have just wound the wick up a little bit more because I can feel the transformer getting slightly warm, and that shouldn't happen because we're connected on the cathode side of these rectifiers. So one of these rectifiers is leaking, and actually this one, which is the one it's connected to, is very, very hot. So I think we found our problem. I think we may have a faulty diode which is leaking backwards. Okay, so at this moment it looks like one of these rectifiers, possibly this one, as this was the one that got very hot, is actually leaking in the opposite direction. Now, judging by the resistance readings I got, it looks like it's actually just completely internally shorted. So I'm going to desolder this one from the board, and I'm just going to test it and see if it's actually okay. And I will probably test all of them to make sure they're all good. So I need to desolder these from the board because I can't actually test them on the board because I'll get a dud reading. Because A, they're all in parallel, and B, there's other circuitry in parallel with them as well. So that wouldn't really be good. So anyway, I'm going to try and use this soldering station. I'm not sure I'm going to have much luck with this tip, to be honest. I might have to use my retro one because that's got a nice big thermal mass tip, and I mean, look at the size of the leads on those diodes. They're quite big and chunky, so I think I'm going to struggle with this, but I'll give it a go. So for this, I'm going to start off with my desoldering pump, and then I might try some wick. Right, so I'm just going to start with just applying a little bit of flux, and I like to use a paste flux for this particular application. I do also have liquid fluxes as well, but for this I usually find the gel flux is better. And what I'm actually going to do before I attempt to remove the solder, I'm just going to apply a fresh bit of solder to the joint, because sometimes that does actually help to wet a little bit of fresh solder into the mix, and it cleans off any oxide on the surface of the solder that's originally there, and hopefully should help it melt a little bit easier. I am so going to need that other tip. So I've got my little desoldering pump. Right, let's give this a try. See what we can do with this. Well, it's not bad for a first go. Oh, okay, that's good. Right, I'm just going to wick some of the solder off of these pads. Yep, that's pretty good. Yep, that's perfect. Right, so I've removed the diode from the board, and it's obviously going to be some sort of Schottky diode. Let's have a look at the part number. What is it? It's a SB5100. Oh, that's alright, that's a standard part. I actually think I've got some of those in as well. That's good. Right, so let's test this diode and actually see if it's any good. I suspect it's probably not going to be any good. I'll just put my my multimeter to the diode test, and we'll put the red probe on the anode, black on the cathode, and we've got absolutely zero voltage drop, so that looks like pretty much a dead short. So if I actually put it onto resistance now and do the same test, as you can see, that's reading 0.3 ohms, which again is going to be the resistance of the leads. Yeah, it's pretty much almost a dead short. And the way you can tell is if you do it the other way around. So if you put the red probe on the cathode and the black probe on the anode, it shouldn't actually read anything. It should read infinite, because it's actually should be blocking the voltage from the multimeter. And as you can see there, it's actually reading, well, continuity. It's basically reading a dead short. Right, now with that diode removed, let's do another quick check and see if our short circuit still exists. Now what I'm expecting, again, as I said last time, it will probably initially read a low resistance, and then the resistance will shoot up and start climbing. I'm not expecting to see an open circuit, because obviously there are other components in circuit with these. So let's just see. And yeah, as you can see, the resistance is climbing. Yeah, as those capacitors start to charge up, that will just keep going up and up and up, and eventually, yeah, it will settle down on a very high value, pretty much. So that's good. I'm pretty happy that that short circuit has been removed. Well, now I'm pretty confident that if I just change this diode, we pretty much fix the problem. Now I'm going to see if I've got any of these in, and if I have, I'm actually going to replace all three, because it's pointless putting a brand new diode in there amongst two old ones, because the chances are if that one's failed, those two aren't going to be far behind. They're probably half dead already. And the other reason is you shouldn't really put diodes in parallel that have got slightly different characteristics. And obviously the one I'm putting in there is brand new. It's from a different batch, different manufacturer, and as diodes age, their characteristics change. And if you put one in that's brand new and keep these two in there, they'll have different electrical characteristics, and possibly they could end up failing prematurely. So I don't really want that. So for the sake of literally a few pence, because that's what these cost, honestly guys, they cost pennies. So I'm literally just going to replace all three. So I'm going to, first of all, I'm just going to power the board up and see if it actually works with just those two in circuit. And if it does, and we fix the problem, I'll go ahead and change all three. Right, so I'm just double checking the power supply to make sure it's switching properly and make sure everything's outputting as it should do, because the last thing you want to do is just assume that you fixed it and bung it straight back in the TV and then actually do damage to things further down in the line inside the TV because you never actually checked and it's not outputting properly. So, right, so I'm just going to double check the output, and it's outputting slightly low, but that's because there's no load on the power supply, and obviously in order to be stable there has to be some sort of load on the power supply. So that seems to be okay, so I'm going to pop that straight back into the TV and we'll see if it fires up. Well, I'm just going to put two screws in for now because I just want to test it. I'm going to have the board straight back out again anyway, so it's just to stop any connections getting broken. So that's all in. Let's put the power cable back on. Like that, and we'll flip it over and we'll plug it in and test it. Right, let's just fire this thing up and see if it works. Right, we've got a flashing power light. That's a good sign. Something's happening. Okay, is it going to fire up? Ah, result. Look at that. Brilliant. Let's go to menu. Yep. Right, excellent. So that's all working. Let's just unplug that again. Right, excellent. That's going to be a nice easy fix then. So I'm going to take this power supply board back out again and we'll put the TV aside for a moment. Now I'm going to replace all three as I said before, so I'm just going to double check now and see if I've got some of these in. I'm sure I have. Now I always keep a good stock of assorted electrical components, things that I use all the time like transistors, plenty of diodes, you always keep those in, 555 timers, 34063s, and I've also got a drawer here for Schottky diodes, and I'm pretty sure these are going to be SB5100, which is exactly what we need. So I had a pack of those handy. This is why you always keep a load of different assorted components in stock, because if you're trying to repair something you never know what you might need. So this is why I always keep plenty of stuff. Right, brilliant. Now I know I've got plenty of these, I can go about replacing them. Now I only need 3 of these, so let's peel 3 of these off of here. These have got nice big thick chunky leads on these, so I'm just going to kind of bend them into shape, and I'll use the one that I already desoldered as a template. And yeah, that looks pretty good, so I'll go with that. So I've just got to do that to all 3. Now I know these diodes are obviously brand new and just out the pack, but it's always a good idea to just test them anyway before you put them in, because you know, if you've got a dodgy one from a dodgy batch or something, you want to find out before you put it in rather than after you've put it in and put it all back together again, because you'd be screwing if you did it that way around. So also this gives me the opportunity to show you what a healthy diode should do. Now if we put the red lead on the cathode and the black lead on the anode, we shouldn't actually see anything on the meter. It should just say OL, okay, which it obviously does there, you can see that. If we do it the other way round and put the red lead on the anode and the black lead on the cathode, we should see a voltage drop across this diode, and because this is a Schottky diode it should be about 0.25 volts, 0.25 or somewhere around that. And it's actually 0.269, which is, you know, kind of expected for this type of diode. So that's perfectly fine. I'm just going to check them all and see, and just make sure they're all kind of within limits. So what we have here is three perfectly good diodes, so we can put those in now, and I will just have to desolder the other LEDs, other diodes off the board, and I'm going to use the same technique with the old desoldering pump, and then I'll use the braid to wick off the solder and clean up the joint. And what you want to do, I see a lot of people with this wick where they put it on and then they drag it away. You do not want to do that, because if you get a bit of solder that's stuck to the pad, you'll actually tear the pad right off. And I've seen it happen, and it has actually happened to me. I've learnt the hard way, so don't do that. Once you press the wick on, peel the soldering iron and the wick off at the same time, but don't drag it around the board, because you will seriously pull a pad off. I've done it. It does happen, so yeah, just be warned about that one. Okay, that's fine. So those pads are nice and clean. Those two could do with a little bit more actually. So I'm just going to put my 3 new diodes in now, making sure they're the right way round. The coloured band at the end there goes this way round with the coloured band on the silk screen. So just make sure you get that the right way round, otherwise you'll end up with yeah, problems. I'll just put it that way, problems. I'm actually using 0.5mm solder here. I'm using very thin stuff. I actually prefer that for PCB work, because you don't end up sort of overloading the pad with solder that way, and I actually prefer that. So that's one side. It's going to take quite a while to heat up because they're quite big leads. And that's the other side. Perfect. So we'll just do the others. I think we've actually got a big storm on the way over, because I saw some flashes in the sky earlier and I can very faintly hear some thunder in the background. So I think we might have a big storm brewing. A storm's a brewing. That sounded really piratey then, didn't it? I really wish I could put some music on in the background. I've got a really nice sound system out in this lab. It's an expensive one, and I can't bloody use it, because if I upload a video onto YouTube with music in it, Google will put me in prison for 500,000 years. It's pathetic really, isn't it? You can't even just put a bit of music on in the background, but there you go. Such is life. Okay, so that's all the diodes now soldered in, and there's the old ones. They're going in the bin because they're knackered. Well, one of them is. I don't trust the other two. So that's all done. The one thing I am going to quickly do though before I put this all back in is I'm just going to get some isopropyl alcohol and clean off all that flux residue, as I call it, cleaning off the evidence. You don't want anyone to know you've been in here really, if you want to do a professional job. So clean up behind yourself and take all that flux residue off. This is no clean flux, but I don't really want to leave it on there, so I'm just going to clean that off. And I like to just use one of these little brushes that you can get from the art store, just the cheapy ones. And you can also use a toothbrush, that's quite good as well, but I just use this and put plenty on. Now the thing is with the isopropyl alcohol, all it really does is just dissolves the flux residue. So if you was to now leave that to dry, you'd get this white haze all over the board. So now I've done that, what I like to do is just get a little bit of paper towel and just dab it and soak up the alcohol, and what that does is all of the dissolved residue is now stuck on that, and because of the nature of isopropyl alcohol, it will basically just evaporate after a few seconds and leave you with a nice clean dry board. Actually this TV, compared to most, this TV is actually a doddle to take apart and put back together. Some of them are a right pain in the arse. Right, this is the bit that we've got to be careful of, because I've got to plug that connector back in there, and I've also got to put the power connector back through the hole in the back in and connect that back up to there. Mustn't forget that. Okay, now before I push this down, I've got to snap the row of clips in, which is all around the outside. You can obviously hear them snapping back into place. Again, modern day TVs are made from cheap nasty plastic, so they do kind of sound like they're breaking. No, that's all good. Okay, remember we kept all our screws nice and safe, so we can go ahead and pop all those back in now. Now we'll just go ahead and put all the screws back in the outside of the TV. I just don't believe it. And now we just put the stand back on and pop the little plastic cap with the screws back over the top of that. Then we can go ahead and screw the stand back on. Right, that's it, done. Okay, so TV's all back together again, and it's actually plugged in and switched on. So, moment of truth, let's see if it fires up. So let's take it off of standby, and we've got a flashing LED for the standby. That's good, that means it's firing up, it's booting up. And there you go, it's fired up. Hey, so we've got a message at the moment that says it's got no channels. It's because there's no aerial plugged in. What I have actually done though is I've got a VGA cable plugged in the back, and that's plugged into my little PC down here. So let's just put it onto the VGA channel, and bingo, look at that, sorted. So we've got a picture on the screen, everything's all good, and that's working exactly as it should. So I'm well happy with that. Now, what I'm now going to do though is I've got a test video clip on this machine, so I'm just going to run that, and I'm just going to run the TV for a good few hours, let everything get warmed up inside, let all the components heat up, and just run it for a test for a good few hours, make sure it's all good. And if it passes all of that and it's still working, then I'll give the guys a call, tell them the good news that their TV is fixed, and I'm sure they'll be very happy. So there you go. Hope that was interesting. Now, I will be honest, this one was actually quite easy. Sometimes they're not as easy as this, and you end up having to replace multiple parts. And I was quite lucky. The parts for this one were standard off-the-shelf parts. They're stuff that I had in stock, so I was able to just do it straight away. But sometimes you find they're really obscure parts that you haven't got in your collection, and you actually have to specifically go out and buy those parts. And the trouble is, it's a bit of a risk, because unless you 100% know that those parts are going to fix the TV, until that point you're basically throwing money away, because you don't even know if those parts are going to actually make the TV work again. And sometimes, you know, you end up having to sort of just cut your losses with it, because you're going to end up wasting too much time, too much money, and it is simply just not worth it. So there you go. Now, if you are using the information from this video for, you know, following along at home, as I said before, please be careful, because if it's connected to the mains, basically you've got mains potential in there, but as well as that, you've got things that are above mains potential. I mean, you saw in there, those caps were charged up to nearly 400 volts. That is not something that you want to be touching or prodding around with. So as I say, please be careful. I do not want anyone injured as a result, or killed as a result of my information. So guys, I want a clean conscience, so please be careful. Yeah, so there you go. Hope this was interesting, and if you've got any questions, feel free to bung them in the comments section below, and I'll get back to you as soon as possible. And also I will I'll put any information in the description. Don't worry, it's not turned off or broken, it's just the computer went to sleep. I know that's what you were thinking. You were thinking, oh, it's just died again. No, it didn't. So there you go. Hope you enjoyed. Thank you for watching. Nice one.